Hello, welcome. My name is Alok and today we will be exploring the concept of gravitation. So basically, whenever we leave an object from this particular height, it direct fell down. Okay. Or we can say Earth attracts this one. Okay. Another significant example you can say whenever we are rolling down a hill or whenever we are bicycling on a slope of a hill, what you can observe, you need not to pedal that particular bicycle. Bicycle goes down on its own. And the third thing, Earth is spherical and we are not residing inside the Earth. We are on the surface of the Earth. So if you can imagine, there is a ball and there is some nails over it. So why didn't this nail or people us didn't fall apart from the Earth? So all these things have a single answer known as gravitation. Okay. So throughout this video, we will understand what the gravitation is, how it works, and how scientists came to know about this phenomena. Okay. So let's begin with the concept. So it all started in year 1687. A famous scientist, Sir Isaac Newton, was sitting in a park under a tree. So basically what happened, suddenly a fruit fell from that particular tree on the ground. So he thought, why didn't this fruit fly away? Why Earth pulled or attracted that fruit? So answer lies in the question itself. The fruit was being attracted by the Earth, and here is the answer. Earth possesses a kind of force, a kind of attraction force like magnet do. So this force is called gravitational force. What is the peculiar or main difference between these two forces? Magnets sometimes repel. If we bring two same pole towards each other, they will repel. But gravitational force always attract. Every small and bigger object have this force, be it celestial bodies, be it this chair, be it this stool or anything. Every object is have this gravitational force. So by the time scientists studied this force in much detail, and what they find out, like if there is a bigger body or having more mass, it have more force. So what we concluded, the force of attraction is directly proportional to mass of the object. Two objects having different mass, one is bigger, one is smaller, so bigger one will have more force of attraction and the smaller one will have less force of attraction. Another thing that scientists observe, if we increase the distance between these two bodies, basically what happened, force of attraction reduces. So force of attraction between two bodies is inversely proportional to the distance between them. Basically, when we square the distance between them, that is the proportionality that happens. The very third thing what they observe, like there are some small force, there are small object like pen, pencil, but they do not attract each other. If we place a pen on table and another copy on the table, they will not attract each other. Why so? This is the natural question generally arises in the mind. So here's the answer. So basically what happened, we are on the surface of Earth. So Earth also pulls us. So the force exerted by the Earth is much larger than the force that particular pen and that particular copy is having. Okay, so that's why they do not attract each other. Another force arises in the mind, like if we are on the Earth and we are applying, or Earth is applying force of attraction on us, so do we. So why don't we attract the Earth? Why always Earth attract us? So here comes an example. Consider you and your friend. One is having weight of 80 kg and one is having weight of 30 kg. If they are having a rope and pulling each other, so what you think? Who will win? Obviously the one who will having the larger mass. Okay, greater the mass, greater the force. So due to inertia, basically this one is an inertia. Due to inertia, we can't pull Earth. So Earth pull us. So if we are talking about the formula, basically what happened, formula goes like this. Our force is directly proportional to the mass, product of masses. So F is directly proportional to M1, M2. And our force is inversely proportional to the distance between these two objects. So basically what happened? Divided by R square. So what, in order to remove this proportionality, what we do, we introduce a term called capital G, universal gravitational constant. And here comes the formula, F is equals to G m1 m2 upon I square. Using this formula, you can calculate the force of attraction or gravitational force between any two objects. Okay. So here was the brief of gravitational force. For more detail, stay tuned. Thank you.